Okay, hello. You should see the desktop by now, and you should hear me. Does it seem like everything's working?
Sounds
Yes.
like it.
Okay, great. People are, so a bunch of people have come in. Okay. There. Okay. Okay. So today is the second exam, which will be available when class is over. So today, we can, if there's more questions about the review problems, we can go over more review problems. Otherwise, we'll talk. We'll start talking about. Well, we'll see. First, let's see if there's anybody interested in looking at more review problems. So,
Could
here's,
we go over problem 17?
okay, sure. Okay, so here's the list of problems. Let's go to 17. Okay, so let me go ahead and go to Java Visualizer so we can write code there. Okay, so 17. We take this and put it in the Java Visualizer. So this is a method. So it would go alongside of the main method. So now we have two methods here. We have the main method with nothing in it right now, and then there's this is inside. Okay. Now, the problem says, there's nothing wrong. It says rewrite it so just a single statement. Okay. Now, if you go over here and compile it, there's nothing wrong with it. See, it compiles, and if you run it, so it gives you back a Boolean answer. So if I want to try it, I would say Boolean B equals is inside, say, 6. Okay. And if I want to see how it works, okay, so step forward. Okay. So true. See, it tells you whether n is inside of the range between 0 and 100. Okay, so it worked. Okay, now let's see about the problem is to make this. Notice it's 3 lines of code. It doesn't need to be 3 lines of code. It only really needs to be 1 line of code. So the problem says rewrite the body so there's just a single statement, which is the simplest statement that will work. Okay, so what will be the simplest thing that can work? Okay, now let's think about what this does. It's returning a true or false answer. So it declares a variable inside and says it makes a guess that the answer is false. So it declares a variable and says I haven't checked it hasn't even looked at this input yet, but it's just going to guess that the answer is false. Then it says if n is greater than 0 and n is less than 100, then make inside true, because we know now that n is inside the range from 0 to 100. Then it says return inside. Okay, so that makes sense. First, guess that the answer is false. Then check whether the n is actually inside the range or not. And if it is, to say no, change our guess to true, and then return our guess. Now think about it this way. If this thing is true, inside is true, so we return true. If this thing is false, then we keep inside as false, so we return false. Now say that real slowly. If this is true, we're returning true. If this is false, we're returning false. Okay. If this thing here is true, so notice what we're returning is this thing here. Think of it. Okay. if this thing is true, return true. If this thing is false, return false. In both cases, I'm returning this. So here's how I can write that. I'm going to I'm going to write it a second time. And I'll just call it inside 2 here for the second version of it. And what I'm doing is, again, when this thing is true, I'm returning true. When this thing is false, I'm returning false. This thing is what I want to return. And I don't need any of the others. Oops. Notice what it's saying. Return the fact that n is greater than 0 and n is less than 100. What if n is between those numbers? Well, if this is true, I'm returning true. And if this is false, I'm returning false. So I'm returning the right thing. Okay, so can check, try each version. Oh, make this B1 and make this B2. Try both versions. Okay, now the first version it makes this guess, then it makes this check, then it returns what the final answer is. Okay, the return value is true. And the second one just says, well, if n is greater than 0 and n is less than 100, well, then that's what we mean by inside. That's true. If one of these is false, so if it's not the case that n is greater than 0 and n is less than 100, then if it's not this case, then return false. So this case, it's just going to return true. So you just check that thing all in one step and returns true. And if I check something like 600, 600 is not between 0 and 100. The first one, first it guesses that inside is false. Then it checks the inequalities. In this case, it's going to find out that the inequalities are not true, so it's not going to change inside. So inside's still false, and now it returns inside. Okay, and the other one just says, well, is this true or not? If this is true, return true. If this is false, return false. Right now, this is false, so it's going to return false. So, okay, so that's all it took. It just took one line. And this is pretty common. When you're returning a Boolean, you don't really usually need a variable that says, okay, the Boolean might be false and then change it to true. A lot of times you can just return the thing you're checking. Okay, that is true or false. So that's our Boolean return value. When this guy's true, we want to return true, and when this guy's false, we want to return false. Okay, so that's what this problem meant by find the single statement. Now, since it's a method that returns something, if it's only one statement, it's got to be a return statement. A method that returns something has to have a return statement. So the hint here was that if it's a single statement, it must be a return statement. And then it says, what does the method when does the method return true and when does it return false? It returns true when this thing's true. It returns false when this thing is false. So that's what we wanted in the return statement. Okay, does that make sense? Okay, it's a little trick you get used to. There's nothing really wrong with writing this. You know, it's 3 lines when you could write just 1 line, and a lot of people do write it that way. But eventually you get to where you get comfortable, you get used to saying, well, this is just telling me whether this thing is true or false. You know, all that stuff is really just saying whether this part here is true or false. So just go ahead and return it. And actually, the way I wrote this, you don't even need the parentheses. You could even write it this way. They don't need to be grouped together. We're returning whether n is greater than 0 and n is less than 100. So you can see the parentheses weren't even needed.
Question, Professor. So let's say, obviously, we're out in the real world and we're programming and whatnot. Would the proper way to do it be like you did it in the first step or the second step?
Oh, this would be really the proper way to do it. Though this wouldn't be considered too wrong by very many people. This would really be the way you'd see most programmers do it.
Okay.
Yeah, just it's real simple. You're returning the fact that n is greater than 0 and n is less than 100. Okay, so this would be the preferred way, but this would not probably cause anybody any real problems. Yeah. Okay, and sometimes when the functions get more complicated, this is a nice way to do it. Start off with the answer being false, then check if something changes your answer, then return your answer. So that's not a bad strategy. Just assume the answer is false, check whatever you need to check if the answer should be changed to true, then return it. Okay, but in this case, it's simpler to you can just do it in one line. Okay. Okay. So again, what you were given was right, but it could be written shorter. Okay. Okay. Now, what about other problems from other questions?
Could you look at number 18, please?
Okay. Well, it's another one of simplify. Okay, so these were 2 in a row of simplify. So let me copy this one over to the visualizer also. Okay, it's another method, so I won't replace what's in the visualizer. I'll add this method to what's there. Okay, so now there's the main method, and I can use the main method to test this method. Okay, and again, it's real similar. It returns an int. So int n equals, and then I give it it takes in an integer. So it takes in an integer and returns an integer. And it really doesn't do anything particularly useful. It's just you have to understand the logic. It's going to give me, like if I give it 23, I'll get some answer back from it. Okay, so I'm going to give it the number 23. Okay, if 23 is less than 0, return -1. Well, 23 is not less than 0, so I skip over that. If 23 is between 0 and 1, I return 0. Well, 23 is not between 0 and 1, so I skip over that. If 23 is greater than 1, I return 1. Well, 23 is greater than 1, so I'm going to return 1. Okay, and then I return 1, and I'm up here, and n becomes 1. Okay, notice there's a little comment here that says you never get here. Now, let's see, why is that the case? Why do we never get here?
Well, you're accounting for every single possible integer in the if and then else if statements.
Right. Even though there's no catch-all clause here, there's no default clause. If you notice that any integer is either going to be negative or it's going to be, okay, it's either negative. Now, what is this actually testing for? Notice that it says n greater than 0 and n less than or equal to 1, but it's an integer. So what is it really checking?
If it's equal to 0 or 1.
Yeah, the inequalities were really kind of a red herring here. Since they're integers, there's nothing between 0 and 1. We've already accounted for all the numbers less than 0 here. So this is checking if it's 0 or 1. And then up here, it's strictly greater than 1. Okay, so notice that the problem had a hint. The problem had a hint. What are the mutually exclusive cases? There's 3 answers: -1, 0, and 1. And this answer you never get to because every integer is either less than 0, 0, 1, or strictly greater than 1. So every integer is going to fall into one of these three cases. So these are the three mutually exclusive cases. This thing never gets executed. So we can drop that line of code if after we rewrite it. Okay. So the three cases are the negative numbers, the numbers strictly greater than 1, and 0 and 1. Okay. Now, question is, how do I write mutually exclusive cases in a better way than this? How can I write that more clearly, saying that there's only three cases? Okay, you're either negative or, well, actually, here I can say, well, this would have been easier written as you're 0 well, actually, let's think about this one a little bit. This would ask that n is greater than or equal to 0 and n is less than or equal to 1. Well, what integer is greater than or equal to 0 and less than or equal to 1?
0 and 1.
Well, no. It's saying what in, see. Yeah, 0 is equal to 0 and less than or equal to 1. And 1 is equal to 1 and it's greater than 0. Okay, so 0 and 1 make 0 and 1 are the only integers that make this true. Okay, 0 is equal on this side and 0 is less than or equal to on this side, and 1 is greater than here and 1 is equal here. So 0 and 1 make both of these true. Okay, now if an integer is not less than 0 and it's not 0 or 1, there's really nothing else left. So we don't have to check that this is the case. We can just do that. And we never can get down here. So the answer was like this. This is the simplified version. It doesn't simplify a lot, but it simplifies a little bit. Or another way I could simplify this is if I wanted to make it clear, I can write n is 0 or n is 1. Now, I think that would actually simplify it, make it a little bit easier to read. Okay. N is negative, return negative 1. N is 0 or 1, return 0, otherwise return 1. Notice that here I don't put anything because those are the mutually exclusive cases in the original code was that there's less than 0, 0 or 1, one of those two numbers. Every integer is going to make one of these three things true. Every integer is either negative, strictly greater than 1, or it's one of these two numbers, 0 and 1. So we never get down here. So this would simplify the code to something that's just a little bit easier to write. Yeah, it simplifies it a little bit, makes it a little bit easier to read. I've got three cases, negative, 0, 1, and everything else. So everything else now would be the numbers all strictly larger than 1. And if I wanted to, I could put a comment here and strictly greater than 1, but that would just be a comment. It doesn't need to be part of the code. Okay. Okay. Now, yeah. Okay. So that simplifies it a little bit. Now it's not a big simplification. It's a little simplification. Essentially, what it did is it got rid of this because we can never get there, and you didn't need this third case here because once this one's false and this one's false, because of we're working with integers here, and all integers are either in here, or in here. So if they're not in here, they must be in here. So we can make this the default case. So another way we can write this is we can think of this as the default. Okay. All right. So there's the just a little bit simplified. There's the little bit simplified version of it. Okay. It's a little bit easier to read. By thinking about how making a simplifier, by simplifying it, I make it a little bit easier to read. There's one less condition to consider. This thing's not here when it should. There's no reason to have that there when it never can be executed. Oh, one thing that's, let me go back to this one and show you something that's a little bit quirky. So let me do another Java visualizer, go back to that one. Okay, here's something that's important though. We never can get there, right? So why bother with it? Won't compile now. Now, this is actually part of the real issue of this problem. What can be why would this be the case? Okay, if we go back, we had that return statement, but we never get there. On the other hand, if we remove it and we try to compile it, the compiler says, no, you can't, you're missing a return statement. Okay. The compiler doesn't read this code very carefully. Here's what the compiler says. And it's just kind of, it says, if something happens, if something's true here, you return this. And if something's true here, you return this. And if something's true here, you return this. But what if that's false, and that's false? What's the compiler's worry? Suppose the compiler says, well, that one could be false, and that one could be false, and that one could be false, then what?
Well, then it would have nothing to return.
It would have nothing to return. Now, we're smart enough to realize that you can't have all three of those be false. One of them has to be true, but the compiler isn't clever enough to figure that out. So the compiler says, because you're using else, your compiler is saying, well, if this is true, return that. If this is true, return that. If this is true, return that. But what if all three of those are false? You didn't tell me what to return. So the compiler wants there to be another return statement, even though you never get to it. That means we're smarter than the compiler. We know we never get to this, but the compiler doesn't know we never get to this. But what we really should do is not have had that third if statement. See, that we know that we can't have that one, we can't have all three of these false. So if this one's false and this one's false, this one's got to be true. So if we remove it, then the compiler is okay with us getting rid of that one. See, now the compiler is going to be okay with us getting rid of that one. Oh, I forgot a semicolon. I always forget the semicolons. Okay, now the compiler's reasoning now is, well, if this one's true, you return that. If this one's true, you return that. What if both of those are false?
And you return one.
Return one. So the compiler realizes, oh, there's no issue anymore. You know, if that one's true, you return that. If that one's true, you return that. And if both of them are false, that's why this is the default clause. You return this. So there's no problem now. There's each branch has a return statement, and there can't be a fourth case. Okay, but as soon as we put that thing, as soon as we put that thing there, even though it logically doesn't need to be there, that fools the compiler into thinking that that could be false, that could be false, that could be false, and so you better have another return statement for all the four cases. You could have put another else there. And that would, the compiler would be happy with this, though your boss wouldn't be happy with that, because now you got an else clause that can never happen. Okay, now this would work. The compiler was happy, but now your boss would say, you're writing code that can never happen. Because this is an integer, every integer is either negative, 0 or 1, or strictly greater than 1. You never get to this thing, so you shouldn't even have it there. This should be your default case. Yeah. So that's kind of that's part of the quirkiness of it. Sometimes the compiler, you'll get code like this where the compiler will complain that you don't have a return statement. You know, code like this, you know that there doesn't need to be another return statement, but the compiler will still complain. That's why sometimes you have to rewrite these things. And sometimes people will just put a dummy return statement. That's actually considered a really bad idea. Like having a dummy return statement, like we had a minute ago, like this. Having a dummy return statement is considered a bad thing. You know, a return statement that never gets executed just to keep the compiler happy. That you should go back and rewrite the if statements, not have a dummy if statement there. You know, when the compiler complains that you're missing a return statement, the bad solution is just to throw another return statement in there to make the compiler happy. The good solution is to figure out why you didn't, what you didn't quite do right here, that you need another return statement, even though you don't need another return statement. And yeah, the answer was get rid of this guy. Okay, get rid of that guy, and you don't need that other return statement. And then also, I thought that this is kind of a weird way to write this. Okay, so we're really saying, is n equal to 0 or is n equal to 1? Okay, so there's a slightly nicer way to write that condition. Okay, so now it's real easy to read. The compiler is happy, and it's pretty clear what this is doing. It's returning -1 for the negative numbers, returning 1 for the numbers that are larger than 1, and returning 0 for the case of 0 and 1. Okay? Okay. Now, how do you do a problem like that? By in your mind, stepping through the code and asking, when does that happen? When does that happen? When does that happen? And keeping track of the accumulated conditions. So when you read an if, else if, mentally, you need to keep track of the, like, okay, this took care of the negative numbers. Okay, we still have to worry about the 0 and larger. Oh, look, this one took care of 0 and 1. Okay, that leaves, we've done the negative numbers, we did 0, we did 1, that leaves all the numbers larger than 1. Okay, this one does all the numbers larger than 1. We're done. That's all the cases, but these have been done as else ifs. So that means I still need a return here. And so now you see there's a problem. You've handled all the cases here, but you didn't give this a default clause. So then you could say, oh, I can drop this one and just make return 1 the default clause. So so what you learn to do is, as you read a if else, you in your mind have to keep track of the cases and know when you've done all the cases, or realize, oh, there's a case missing. So what you're looking for is that by here you've done all the cases, so you didn't really need this, or that another thing to worry about is that you're missing a case. Okay, let me show you how you can miss a case. Look at this one. Oh, okay, now here the compiler is going to complain about me needing another return statement, but the compiler is actually really right now. Okay, so now the compiler is going to say missing return statement. Now let me analyze it carefully. This takes care of all the negative numbers. Okay, so I'm still worried about 0 and above. Okay, this takes care of 0. So I'm still worried about 1 and above. This takes care of above 1. No more cases. What's wrong?
It's missing the case for if it's 1.
Yeah, so now the compiler is actually right. I am really missing a case. I need to have another return statement. I either need another branch of this if thing, or I just need a return statement by itself, but I really forgot something. Now the compiler now is correct in warning me I forgot something. I handled all the negative integers. I've handled the 0 integer, which now I've handled the negatives, I handled the 0. Now I've got 1 and above to worry about. This one does above 1. I never took care of 1. I kind of have a hole in this logic. That's subtle to find. That's not so obvious. So you have to like read this and accumulate in your head the cases. And you have to make sure that you are covering all the cases. And so the compiler warns you when it thinks you're missing a case. Now in this case, it's right. In the other case, it was wrong. Because if I do this, now I'm not missing any cases, but the compiler doesn't realize that. See, now the compiler is wrong, because now I am taking care of all the cases. All the negative numbers, the 0 case, that leaves me 1 and above, and this one does 1 and above. So now I am right, but now I don't really need that. I can drop that and it's still the same logic. This would be the negative case, this would be the 0 case, and this would be everything else. See if I do that. This is everything else, which is 1 and above. So I didn't need the extra case. Tricky stuff. This is the trickiness of these nested if-else statements. Okay, they can be a little bit. You have to concentrate on them when you write them. They're not automatic, because you have to worry about, are you covering all the cases? And the compiler makes an attempt to help you know that you've missed the case. Yeah, if you miss a case, it helps you. Okay, all right. Okay, now, what about other problems from the review problem?
One question on problem 18.
Uh-huh.
Can you just delete the condition in the middle instead? Just
Can I do what?
delete the condition in the middle. Yes, just.
Oh, mean like get rid of this?
Yes, and then
No.
just add at the end else return 0.
No,
and leave
because once you hit the else, you're done.
Yeah, but there you can just write else if n is bigger than 1.
It won't. No, Java language won't let you do that. It makes sense to us, but not to the language.
Yeah, but then put the else at the end. Else return 0 at the end.
Oh, I mean like, oh, I see. You mean like
Yes.
completely reorder the cases.
Yes.
Yeah, you have to worry about whether you're making it hard for people to read or not. Yes, you can, if the cases are mutually exclusive, you don't necessarily have to have them in the right order. Yeah, so yeah, the else has to be at the last. Okay, it does have to be at the end. Now, like, what does this one do? Okay, takes care of all the negative numbers, then takes care of all the numbers larger than 1. Then what's left here? What case is that?
0 or 1.
No, yeah, 0 or 1. Yes. See, this took care of all the negative ones. This took care of all the ones strictly greater than 1. So now this is actually taking care of n 0 or 1. Okay, so that I have to know that, that's maybe a comment I would write, that n is 0 or 1 here. Yeah, now notice that, it's kind of a funny order. Do the negatives, do the numbers that are negative, do the numbers that are larger than 1, then do the in-between case last. Yes, you're allowed to do that. Okay, Java won't mind. See, Java will be perfectly happy with this. Okay, see, it compiles it. People tend to want to make the cases in the logical order, like, oh, the negatives, then the 0 or 1, then the positives. But sometimes, especially it's only like 3 branches like this, that's fine. That's actually not hard to read at all. Take care of the small numbers, the ones less than 0. Take care of the big numbers, the ones greater than 1. Then take care of what's in between, 0 or 1. Okay. See, with 3 cases, it's not that hard. It doesn't really matter what order they're in. If there was 10 cases, when you start having a lot of these branches, you probably want to keep them in a good order, an order that would make sense to other people. But this one, yeah, this is a good way to write it. This is a nice way to write it. Take care of all those, take care of all those, and then here's the default case, what's left over, which is just the numbers 0 and 1. Okay, that's a good point. Now, see, anything that's logically correct, you can write. Okay, you're allowed to write logically correct things. Java, now, suppose I did this. I mean, I think this is actually kind of interesting. If this takes care of the negative numbers, if this would take care of the numbers that are larger, and then this is what takes care of what's in between. But Java won't let you write them in that order. Even though logically this does make sense, This takes care of one case, this takes care of the other case, and this takes care of what's left. But the case that takes care of what's left has to be at the end. Okay, so even though this might make sense to us logically, you're not allowed to put the default case in the middle. You know, you're not allowed to just put the default. Like here, the idea is, well, the negative numbers come first, then 0 and 1 come next, and then the numbers larger than 1 come third. But you can't write it this way with your default case in the middle. So if you want the middle case to be default case, it still has to be at the end. Okay, so that's, you know, there's a lot of interesting things there. There's a lot of things to think about there. This is a nice way to write it, but the default case has to be at the end. Here, the default case is the in between. The default case. Actually, what if I wanted to make the negative numbers the default case? Can I do that? Can I make it so that the negative numbers are the default case? Let me make a second copy of this so you can keep that one there and look at it. Over here, down here, make the negative numbers the default case. So what should I check here? So I need to check something different here and something different here. And then I have to adjust my return values. I want the default case to be the negative. So that's -1 goes there. I want that to be the default case. What can I do to make this work? I want it to be the same logic as up here, but I want the default case to be the negatives.
For the first two, you put if n is greater than 1 and if n equals 0 or 1, and the order doesn't really matter.
Yeah, so n equals 0 or n. Okay, now let's see. If n, okay, this takes care of the large numbers, and for the large numbers, I return, what was it? 1. This takes care of the middle case, 0 and 1, and for that one, I return 0. So now I've taken care of all the numbers that are larger than 1, taken care of 0 and 1. What's left down here?
The negatives.
Negatives. So logically, this and this are the same logic. Okay. Your boss is probably not going to care that much if you wrote it this way or this way. They're both not, you know, they're both okay. They're both readable. They're both correct. You know, there's really no rules here about, you know, you have to do it this one way. But notice how I can write the logic different ways. I have 3 mutually exclusive cases. I made the default case here, the large numbers. I made the default case here, which one did I do? Oh, the default case here was the middle numbers, 0 and 1. The default case here was the middle numbers. The default case here was the negative numbers. And the way it was originally done, the default case was the large numbers. Okay. Mutually exclusive cases can actually be done in any order. You can do them in any order, just have to do it carefully. Yeah. And you have to keep in mind you have to kind of keep track of it in your mind that you're getting these right. Okay, let's check the compiler. Let me call this 2 and just see they both compile. And if you test them, you'll see that they do the same thing. The logic of this one is exactly the same as the logic of this one. That's the same logic as the one we did before. This one. This was the way it was in the problem, where you did the negative numbers, then you did what was in between, and then you did the positive numbers. Okay? All right. So mutually exclusive cases have to be done carefully, but what you don't have to, there's no rule about what order you have to do them. If the cases are mutually exclusive, you can test for them in any order you want, and you can rearrange the order of them if you want. But you do need to make sure you have a proper default case. Okay, what about other problems from here? Notice that solving these problems and talking about the problems is a good way to think about programming. I mean, this is a good way to learn programming. I mean, I wish you guys could get together as individuals, because that's what that's one good way to learn programming, is to do it with somebody and talk about, my idea was to do it this way, your idea was to do it that way, and then you realize that there's just two different ways of doing the same thing, or maybe you realize that one is a little bit better than the other. So it's good to talk about the different ways of doing the same thing. What about other questions from these review problems?
Someone said 19 on the chat.
Oh, okay. Okay. Okay, 19, this one we'll just do here. There's no, this one is not one we want to do in the Java visualizer. Okay. Now, we talked about this before. When you have, like, let me show you where we did something like this. Second, we had these problems that drew, where's we had these puzzles and patterns examples. Okay. Now I can't remember if it's the puzzles or the patterns. Let me download both of them and show you where I'm talking about that there's something similar to what that homework problem is about. Okay, I think it was the puzzles. Yeah. See, we wanted this output. Okay, that's nested for loops, rows and columns. So you have nested for loops for the rows and the columns. But remember, there was two ways of doing it. One way was to have like, see now like this one has two for loops inside here, because one for loop did the first part of the row. So this for loop would do the first part of a row. Then the second for loop would do the second part of a row. So each row needed two for loops, something to step through the first part and something to step through the second part. But then we said you could do it another way. You could use an if statement inside the two for loops and just ask a question about what row and column am I in. So for example, here, the spaces are when the row number is less than the column number. Like take that space right there. What row is it in? Row 1, 2, 3, 4. It's in row 4. Okay. Oh, I'm sorry. This is where the spaces are where the row number is larger than the column number. See, so the row number is 1, 2, 3, 4, but the column number is 1, 2. I'm in the second column. Okay. Now I'm in the second column. So now I'm in row 4, column 2. Here I'm in row 1, 2, 3, 4, 5, column 1, 2, 3. The row number is larger than the column number. So if the row number, if the row number is less or equal to the column number, we print something. And if this is false, so the row number is greater than the column number, we print space. Okay, so we could use if statements and ask questions about what row am I in and what column am I in, and to determine what the output would be based on that. Okay, so a lot of these problems, each of these puzzles had two solutions. Like here's another one. Let's look at another. Oh, these all have, I was looking, I thought one of these had just shapes. Okay, every one of these, you can do it with two for loops, because you have to go across the first part of a row, then you have to go across the second part of a row. So you can do it with two for loops, go across the first part, go across the second part, or you can ask, this picks a row, this picks a column, so this for loop always goes across the whole row. Here, this one did the first part of the row, this one did the second part of the row. This one now does the whole row. But now you ask, okay, can I figure out from knowing what row I'm in and what column I'm in, what I should output? If I know if I look at one spot I know what row I'm in. I know what column I'm in. Does that tell me what to print? Okay, so that's the approach to take in this homework problem. This homework problem sets things up as 2 for loops. The outer for loop goes through all the rows, and the inner for loop goes through across all the columns. And then you know this is what row you're in, and this is what column you're in. And now the if statement asks, well, if I know something about the row and the column, can I print out either a star or a space? So you notice that there's nothing but you either printing space or you're printing star. Okay, so here you either print out star. If all of this is true, you print out star. Otherwise, you print out space. Okay. All right. So now one of these draws one picture and one of them draws the other picture. And what we want to do is try to find a clue that tells us which one of these is drawing which one of these pictures. For example, notice that this picture has nothing here, and this one has nothing there, and this one has something there. Okay. On your hand, there's nothing here, there's nothing here, but there's something in the middle there. Okay. Now they all have in common this top row, the right edge, the bottom row, and the left edge. So they all have that in common. Like now, notice that that's which part of the, now, take this top row. In terms of rows and columns, when do you print a star? What condition do you check for to print those stars?
How much the value n is?
Yeah, so what value specific, what value of n, or not, I'm not n, what variable is counting rows?
I.
I. What value of I is the first row?
1.
1. Okay, that's this guy right here. If I is 1, notice these are ors. So if I is 1, you've hit a star condition. That guy right there gives you that top row. Notice it's all in here. So both of them will draw a top row. All right. What row number is the bottom row?
N.
N. N is the dimension of this thing. So n is the dimension that says that that's the last row. That's this condition. If I is n, you're in the bottom row. So remember, the point of view is here is we've picked an I and we've picked a J. So we're somewhere in this rectangle. And the question is, are we at a space location or a star location? Well, if n is 1, we're in the top row, that's a star location. If I is 1, we're in the top row, that's a star location. If I is n, we're in the bottom row, that's a star location. What determines the left-hand edge? What is the left-hand edge in terms of rows and columns?
J equals 1.
That's the first column. Now, J is the column counter, so that's this guy, J1. That's the left edge condition. See, this one does a left edge condition also. So top edge condition, bottom edge condition, left edge condition. Notice this is or. So if you're on the top edge, or you're on the bottom edge, or you're on the left edge, what's this guy do?
The right column,
And why is that?
because it's J equals N
And J is the
column.
column counter, and N is the last column. N is the dimension, that's the last column. So this is saying when the column counter is equal to the last column, print a star. Okay, so these two lines give us the border. They give us the border, and they all have the same border. Okay, so these two lines in both of them are the same. Okay, so now we have to look at these other conditions. They're the ones that are going to tell us whether, so now we want to look for the stuff that does what's inside, like this part, this part, this part, that part, this part, that part there. Okay, so now we start looking at these things and try to figure out what they're doing. Now they're ors. It's this or this. Now notice that this is an and something else. something and something else. Okay. What does that do?
Prints a star on the diagonal.
Okay, well, no, be careful, because there's a little bit more logic. This guy by itself, I equal J, what does it by itself do?
The row and number and the column number are equal.
Yeah, so it checks for if the row number and the column number are equal, you use the word to say it checks for what?
To see if it's in the same row in the same column.
Which is, and what word do we use for all the stars are on the same row in the same column?
Diagonal?
The diagonal, yeah. There's the check for the diagonal. Now it doesn't print because it also says and something else. So, but it's not by itself. So it's saying, are you on the diagonal and something else? Now notice that here, it's not the whole diagonal. And now here, it's not the whole diagonal. And here, it's not the whole diagonal. So none of them print the whole diagonal. So they're checking for something else. So this is saying, if you're on the diagonal, okay, and this one's a little harder to read. And, okay, what's I?
The row number.
Okay, so if you're on the diagonal and the row is less than, so now row less than means you're in the upper part of something. The row, remember the row 0 starts up here and row increases. So here you're saying, and the row is less than, can anybody tell me what that means?
It's the upper half, including the middle line.
Yeah, so is it in the, is it, well, this guy here, what does that guy measure? N over 2 plus 1 is the,
The middle.
where would, pardon me?
The middle.
Middle, yeah. So this is saying you're less than the middle. So in your upper half. So this one is the thing that says the middle, and then you say I less than or equal to it, you're saying, oh, in the upper half. So we know something now. We know something now. Diagonal and upper half.
Would it be the middle one then?
Yeah, because the middle one's the only one with a diagonal in the upper half. See, this guy is the lower half diagonal. This one's the lower half diagonal. This one's only this one does the upper half diagonal. So we know this one now is the middle picture. This is the middle picture, the one on the left. And and we don't even need to think about this one yet. You know, we don't need to, you know, we could go back. This one should do what? I mean, we know now this is the diagonal, upper half of the diagonal. So then that means this has to be what?
It prints the left half of the middle row.
Yeah, the right half of the middle row.
Oh yeah, my bad.
Yeah, it prints the right half of the middle row. And what's okay? Now let's analyze it. This should be now by process of elimination. Top edge, bottom edge, left edge, right edge, upper half of the diagonal. The only thing left is the right half of the middle row. Okay, so let's check that. Okay, what's I? I measures
Row number.
row number. Row number is what?
The middle row.
Middle, yeah. Row number is middle, just like this was middle here. Okay. Oh, row number's middle, and what's J measure?
The column number.
Column. and column is larger than the
Middle.
middle. Okay, so you're in the middle row, but the column is larger than the middle. So that's this. You're in the middle row, but the column number is to the right of the middle. The column is larger than the middle. If I turn that into a less than or equal to, it would be this half of that line. Okay, all right. So notice that you're turning this logic into real statements about a picture. Okay, so the logic, and the way you do it is you have to tell me exactly what I is. I is the thing that counts the rows. You got to know exactly what J is. J is the thing that counts the columns. Then you look at, well, N is the dimension. So N over 2 is half of that. Okay, and then because we're doing with integers, like if I give you 7, notice that here it says assume that N is an odd number. Okay, so to get an odd number, the middle of it, like the middle of 7 would be the number, let's see. 4. See, 4 is in the, if you think of it, 4 is the middle because it's got 1, 2, 3 on the left and it's got 5, 6, 7 on the right. So if you had 7 rows, the middle row is 4. Now that's N divided by 2 using integer division. 7 divided by 2 is 3, not 3.5. See, this is integer division. We're using tricks like this. This is integer division. 7 divided by 2 is 3, not 3.5, 3, plus 1 is 4. Okay, so the middle of 7 is the number 4 because it's got 1, 2, 3 below it and 5, 6, 7 above it. Okay, and you can try like take the number 11. What's the middle of 11? If you have 11 rows, what row is the middle one? If there's 11 rows, which row number is the middle row?
6.
6. That's got 5 rows below it and 5 rows above it. And then you take 11 divided by 2 is 5 because you drop the half. 11 divided by 2 is 5 plus 1 is 6. Okay, so this is the middle row because we're told here that we're working with n rows and columns, odd number of rows and columns. Okay, so we're assuming that n is an odd number of rows or columns. Okay, all right, so that draws that little piece there, and we know that this thing drew that diagonal there. This guy is either the one on the left or the one on the right. Okay, so this guy is either one on the left or the one on the right. Let's see how fast we can figure out which one it is. What does that do?
It's the diagonal.
Diagonal. And this part here, well, actually, if you look, oh, it's not the same as this one. This one did what? See, this said on the diagonal, and the row is
In the top half.
top half. This says on the diagonal, and the row is
In the bottom half.
bottom half. Yeah, greater than the middle row. Well, that's both of these guys. Okay, so he did not tell us the answer because both of these have a diagonal in the lower half. Okay, so now this is going to be the one that's going to tell us who it is. Okay, now, so this is going to tell us which one of these it is. Okay, this says, okay, I is the what?
Row number.
And this is saying we want the row to be
Oh, the middle.
in the middle row, and the column is what?
Before the middle.
Before the middle. So this draws a horizontal line in the middle on the left. So on the middle row, fill in all the columns that are on the left half. That's this guy. So this one is this one. Notice this one doesn't even have anything in the middle row. So once I saw something on the middle row, I could eliminate this one. because this one doesn't have any stars on the middle row. Okay, but this is saying on the middle row to the left of the center, the left of the middle, center row to the left of the middle. Okay, so these pictures are real good exercises in following your nose through logic carefully. You know, I've noticed I've used every single equal and less than or equal to, and the ors and the ands. You know, it matters whether I'm doing ors, it matters whether I'm doing ands. And you know, this is actually what we're doing here is computer graphics. You know, we're drawing a picture. You know, we're drawing a picture on a screen, and this is actually like a simple version of how we do computer graphics. It's all about going across all the rows and all the columns of your screen and saying, well, if I'm in a certain location, I do one thing. If I'm in a different location, I do something else. So this is a real typical pattern for a computer graphics program. This is a very typical pattern of saying, depending, what I do depends on which row and which column I'm in. Okay, so let's see what we said. The one on the left was the one in the middle, and the one on the right was the one over here on the left. Okay, and then if you want, you can figure out how to draw, like, you know, as an extra exercise, I could have said, and write the code that draws the third one. Because once you've picked these apart and understood how they work, it shouldn't be that hard to write the third one to draw this guy. Okay, it would be a lot like this one because it's got that guy in common. Okay, actually, what would change? It would be, you would do a small change to this one. There's a tiny little change. Actually, there's only, I think, one letter change to change this picture into that picture. I think it's only one letter needs to be changed.
You do j equals n over 2 plus 1 instead of I.
Yeah, okay, we'll see. Which row, which line are you in? Is that this line?
Yeah, that was.
Yeah, okay, this line drew the left half, right? Of the
Yes.
center row. But what do we want here?
The middle column.
The top half of the middle column. Left half of the center row, top half of the middle column, change what to what? Oh, no, we change two letters. We change this to what?
J.
J. So that's saying you're in the middle column. Then you change this to
I.
I to say you're in the top rows. So you swap those two letters, make this a J and make this an I. Swap those two letters, and this picture switches to that picture. See, once you understand how they fit, it's like a machine. It's like a machine that has moving parts, but they're all sitting still. And you make it a machine with moving parts by thinking real hard about the logic. How do these things work together? How do they do something together? So the difference between this picture and this picture was just the difference between that letter I becoming a J and that letter J becoming an I. Instead of doing the left half of the middle row, we want the top half of the middle column. This asks for the middle of something. Change that I to a J, and it goes from being the middle row to the middle column. And this asks for being on the lower side of the middle. See, this is the middle still. This is the lower, below the middle. That would be to the left half of the middle here. That would be above the middle here. So changing the I to a J. So it's about, it's seeing all the logic fitting together and telling a story, or doing something together. Not easy, but this is the kind of training problems that say, here's what your goal is. Your goal is to see this as a thing that paints one of these three pictures, using a kind of a straightforward trick of saying, let I pick the row, let J pick the column. Now you know you're in a certain row in a column, and then you ask, okay, if it meets these conditions, it's a star location. Otherwise, it's a space location. So then you want to characterize, like everything on the top row is easily characterized that way. Everything on the right edge is easily characterized that way. This doesn't work with stuff like this wouldn't work for every kind of shape. Some shapes are too kind of randomish to draw this way. Okay, so this works for shapes that have very specific patterns, diagonals, horizontal lines. Okay, so I mean, you can't draw anything this way, but you can draw a lot of things this way. A lot of things that can be described in nice logic like this. So it's not going to do everything. Okay, you could do one thing you could do nicely here is you could shade things in. Like if you wanted to shade in that region, you could add a piece here that would then put stars all through there and shade in something. So this trick is good for logic when you want to shade things also. Okay. Okay. So you could play around with these. You could if you put this into the Java visualizer, it will it will just give you one of those three outputs, and then you could try making changes to it to see how the pictures change. Okay. What about another problem from the review? Any other one from the review?
14.
14? Oh, I saw somebody wrote 12 too. I didn't see the writing there. Okay, so let's try to do both of those, 14 and 12. Okay. Okay, this one's got something wrong. Okay. Compiler complains. Same kind of problem we had before, missing return statement. So let's follow the logic. What's the missing return statement? Is millionaire. If the net worth is greater than $1 million, true, you're a millionaire. What's the problem?
It has nothing to return if it's less than $1 million.
Yeah, there's a whole nother case. You're supposed to return false when you're not a millionaire. Okay. All right. So we're missing the case of not being a millionaire. Now there's three ways to fix this. Else, return false. That's one way to fix it. See, if this is true, you return true. If this is false, you return false. But listen to what I just said. If this is true, you return true. If this is false, you return false. What's the second way to fix this?
You could just say return net worth greater than or equal to $1 million.
Yeah, because notice I'm returning, if this is true, return true, which is what it is. If this is false, return false, which is what it is. So I'm always returning this thing here. So I can shorten this problem to just be return that. Okay, just like the other one. Okay, and then I put a semicolon at the end. Okay, so it can be shortened to just one line. A third way to solve this one, okay, here's what it was. A third way to solve this one, instead of putting an else clause, I can just say return false outside like this. See, now that's outside of the if statement. So that's by itself outside the if statement, but it still solves the problem. If this is true, I return true. If this is false, I drop down out here and I return false. So now the nicest solution is the one-line solution. The second best solution is the one that uses the else. And this is like the third solution. This is the less good one. So you can kind of lay them out. This is one solution. The other solution is just put an else here. And then the other solution was the best one is okay. There's the 3 ways of fixing it. Just put an extra return statement outside the if statement, give the if statement an else clause, or just say, well, you don't even really need the if statement. Just return net worth greater than 100,000, 1 million. Okay. So there's 3 ways to fix it. Now, let's see, what was the other one? 12. Okay. Now, oh, write a complete definition. Okay, so copy this over to the Java visualizer so we can read it while we're working on it. Okay, so what I'll do is I'll put it down here. Okay, there's the description of the problem. So it's sitting there, we can work with it. Okay, write a complete definition for a public static method called close enough. Okay, so I want public static. Okay, now I have to tell you the return type. The return type, public static, what's the return type? Close enough. And then I tell you what the inputs are. Then I'll need a body. So I'm going to sketch it out. What is the return type? What goes here?
Boolean.
Boolean, because it returns true or false. See, it returns true and false. So it returns a Boolean. Okay. Now, it takes in 2 numbers. It takes a double. So the first number is a double. Then I got to give it a name. And then the second number is an int. You can see the second one's an int. And I need to give it a name. Oops, type it in the right place. I need to give the double a name, and I have an int, and I need to give the int a name. Now, names are kind of useful. Yeah, you want good names. Here, I'm just going to go with something like x and n. Okay, x for the double, n for the integer. I don't really know what they represent. If I know what they represent, I would like to use a word here to help you know what they represent. But here, I don't really know what they represent. So I'll just let them call x for double. We use x's a lot of times for doubles, and we use the integers like I, j, k, n for integers. Okay. Now, I have to return a true or false. Now I have to figure. Returns true if the double is within 1 unit of the integer. So the double has to be 1 unit away from the integer. So that's some kind of inequality. Okay, so let me just sketch it here. Here's x, here's n. What kind of inequality says that x is between, okay, if you think of a number line, here's a number line. Okay. Here's n. Here's n plus 1. That's the next integer on the number line. Okay. There's the next integer on the number line. And then there's going to be another integer down here, n minus 1. There's the So here's a draw a picture to help you think. Here's n. Now x, I want x to be between this number and this number. See, takes it down, and an integer that returns true if the double is within 1 unit of the integer. So I want x to be what? Now I can start saying, what should I write over here to say that x is within 1 unit of n? With this little picture to guide me.
The absolute value of x minus n.
Let's see. Absolute value of x minus n. What about it?
Is less than or equal to 1.
Okay, less than or equal to 1. Okay, now what, X minus n takes this, like, suppose X is over here. So there's X. That would compute, X minus n computes this distance between them. Now, sometimes that distance is positive and sometimes that distance is negative, because if X is over here, see, then X, so if X is over here, is X minus n positive or negative? X is the smaller number, n is the bigger number, so X minus n now is
Negative.
negative. Okay, and on the other hand, if it's over here, X is the larger number, n is the smaller number, so X minus n is positive. But what I really care about is that distance. That's why I take the absolute value. I really just care what's that distance. And I want that distance to be less than 1. Okay, so now I put a math in front of that because that's how Java does it. Math.x minus n is less than or equal to 1. Okay, now that's a Boolean expression. I can just return it. I'm done. Return whether the absolute value of x minus n is less than or equal to 1. Now, there's a little bit of ambiguity whether this should be less than or equal to 1 or strictly less than 1. Okay, yeah, I think it, yeah, the problem leaves it a little bit vague about, when it says return if the double's within 1 unit. Within 1 unit, do they mean including exactly 1 unit or not exactly 1 unit? So there's a little bit of ambiguity whether they meant less than or equal to 1 or just strictly less than 1.
For the third example, it returned true, so I think it's less than or equal.
So it's included in the test. Yes, good point. So included in the test, see, that's why test cases are real useful. So the test cases cleared up that ambiguity. Okay. Now let's do it. Let's do it another way. If you didn't want to use the absolute value function, you can do this without absolute value. Could you go down here? I want my x to be where? Do it now without the absolute value. X has to be where? Can X be over here?
No.
Why not?
It's not between n minus 1 and n.
Right. Okay.
And it's not between n and n plus 1 either.
Yeah. So now turn that back into an expression up here. Like, notice obviously X can't be here. So say the words you just said, turn them into an expression here. X has to be where?
N minus 1 is less than or equal to, or less than or equal to x is less than or equal to x, or n plus.
Okay, so let's do it piecewise. What's this guy saying? This guy says what?
X is greater than or equal to n minus 1.
So it's to the right of n minus 1. So that takes away all these bad points here. You can't be there. And what else? So now notice this by itself says you have to be to the right of n minus 1. So that lets me go anywhere over here. So now I have to say and
X is less than or equal to n plus 1.
yeah, exactly. And now X has to be less than or equal to n plus 1. Okay, done. 2 ways to do it. Fancy way using absolute value, and a slightly more straightforward way, just saying, well, you've got to be between this number and this number. Notice that pictures help a lot. Draw pictures. Find a way, now creative problem solving is about, part of it's about what's the picture that will help me. Now, if you're given a numbers on a number line, draw a number line. Number line is a good likelihood to help. There's an n on the number line and there's an x, and draw a picture. What does it mean for x to be within 1 unit of n on the number line? Well, there's 1 unit to the right of n. There's 1 unit to the left of n minus 1, n plus 1. X has got to be inside there. Okay, so x has got to be to the right of n minus 1 and to the left of n plus 1. And it's got to be both. Because by itself, this just says you're there on the number line. But that includes all this stuff out here. This one by itself says you're there on the number line. But that goes all the way to there. Then you say and. When you do the and, you're saying this part in between, from the left to the right edge. Okay? So these are really good problems. These are all really good problems. These are all real good ways to show you like the kinds of ways you should be thinking, what you need to, how you need to think. Draw pictures. Pictures, programming classes are a lot like math. Pictures help. You know, drawing a picture goes a long way towards sometimes solving these problems. Okay, so if you have other, we're done. So that means the exam's available. So you can go to Brightspace and you can download the exam. It's due at 11:30 this evening. I got office hours after this, so I can't stay for the whole office hour. My wife is still sick. I have to take her to a doctor. So I'm going to have to go to a doctor at 3. So I won't be in office hours for the whole time. But I have office hours starting at 2. So I'll be there for half hour, 40 minutes or so. So if you have questions, you can send me emails. You know, if you have a question, you can send me email. Everyone's supposed to do their own work. You're supposed to work on it yourself, but you can ask me questions, especially if you have clarifications. Thanks. But especially for clarifications, if you're afraid you might be misinterpreting a problem, you want a clarification, send me an email. Okay. All right. So we'll quit there, and let's see. I'll stop sharing, and good luck with the exam. And send me emails with questions if you need clarification or if you want to ask quicker. Like, I'm not going to tell you if you're right or wrong, but I'll clarify things for you. So just go ahead and ask a question, and I can give you I'll definitely tell you if you're misinterpreting a problem. That's the most important thing. Okay, so I'll end the meeting now. Bye bye. Have a nice weekend too.